Kia ora koutou, here's question 1E from this year's Level 2 Algebra exam. So this is a disguised quadratic, and they've given you a hint about what to do about that. So this might not be an excellence question. I'm thinking this could be a merit question because that hint kind of made it, I think, reasonably obvious how to start. It does link up logs at the end, but it's a pretty fast one. So let's have a look at what we've got. Well, we've got 5 to the 2x plus 1 minus 120 is equal to 5 to the power of x plus 2. I'm going to first of all split those exponents up. So I get 5 to the 2x times 5 to the power of 1 minus 120 is equal to 5 to the power of x times 5 squared. So that's just using my exponent properties from like way back in like year 9 or year 10 algebra. The thing to note next, and if you've done these problems, you will have found this, I think, very fast. But if you're new to this and you're doing level 2 in 2026, you might not be used to this. We can split up that 5 to the power of 2x as 5 to the power of x squared times 5 minus 120 is equal to 25 times 5 to the power of x. And now we're going to let u equals, or I think they said let n equal. So let n equal 5 to the power of x. And you can see we've got 5n squared minus 25n minus 120 is equal to 0. So we've got a quadratic. I can divide out my common factor, which is 5. So I get n squared minus 5n minus 24 equals 0. It's a really nice, easily factorizable quadratic. I get n here. What have I got? 8 and 3. So we'll have an 8 here and a 3 here. Minus 8 and plus 3. Okay, so when we come to solve it, we get n is equal to 8. Or n is equal to negative 3. But remember, n is equal to 5 to the power of x. So 5 to the power of x is equal to negative 3 has no solutions. All right, 5 to the power of anything is going to be a positive number. If you think about the graph of 5 to the power of x, it'll look like that. So we ditch that one. Maybe don't do that on your exam paper. That's pretty ugly. And now we're left with just this one solution. So 5 to the power of x is equal to 8. I can take logs of both sides. Using my log rules, I get x log 5 is equal to log 8. I'm using base 10 here because I'm going to bung this in my calculator at the end of the problem. And if I do that, I get x is equal to 1.292. I'm just going to show you that's to 3dp, which is probably good enough. Don't write it to 8 decimal places. It looks really silly. Anyway, the other thing I'm going to show you is how we could do that using log to base 5, which would give me a nicer exact answer. I'm pretty sure that's probably what most of you did. So if we go back to the step up here, we've got log to the base of this is equal to log of this. But I can choose the base that I'm working with, and because I've got a 5 to the x here, let's see what happens if I choose log to base 5. So what logs mean, 5 to the power of what is going to give me 5? And this thing here is just 1, right? So that gives me an exact answer of x is equal to log to base 5 of 8. This one you can't put into your calculator, okay? And so when you're working with logs, usually what we end up doing in level 2 is we work in base 10, which is what we've got here. If there's no log base written here, then implicitly we're assuming that it's base 10. All right, thanks for watching. I'll do the other 4 questions later on tonight.